Uh, Welcome everybody to this session. Can we have the slide, please? All right. This will be a session about the BIM workflow to showcase some of the new tools that we made for V20 and some extensions of existing tools. At the desk for me is Wouter, who will be doing the first part of the demo. I am Jurgen, and we're both with the R&D team at Bricsys. So we want to show the features that we made as part of the typical workflow that we like to promote when using BricsCAD BIM, going from conceptual design with 3D modeling over gradually adding BIM data towards full 3D detailing. So let's start with the modeling phase and revisit a tool that we introduced last year, being QuickDraw. This tool was conceived as a way to very easily lay out your floor plans, your floor levels of a building, and stack them on top of each other to get a complete building. It features a cursor, the room cursor, which in 2 clicks simply creates a rectangular room with slab and walls. But in a few iterations, you can refine this shape to get more complex floor plans. As you can see, the room cursor exhibits a snapping behavior. It snaps to existing walls, also to extensions of existing walls, such that you can really easily align your walls in your model. And then you can quickly add some extra levels and maybe finish off with the roof. So what we have done for V20 is to extend the snapping behavior of this tool. So as you can see here, when Wouter moves the room cursor close to a wall that has a thickness different from the default thickness, the room cursor can adapt the wall thickness. And depending on how you approach a corner, you can choose which wall thickness you will be drawing with. This makes it very easy to work in a model with different wall thickness. Another feature we added is that the cursor now snaps to grids. So if you're designing off a grid, it's very handy that the cursor snaps to grid lines and also grid intersections. So it's very, this helps you a lot to align your building with the grid. And also note that when Wouter adds extra levels, the grid lines are projected onto the higher level slabs, and the cursor still snaps to those projected grid lines. So you can keep on working on this grid. And then last but not least, the cursor also snaps to 2D drawings. So this was already shown in the Ultimate BIM demo, but we want to use this feature as well here to start modeling our demo model. So when Wouter moves the cursor close to lines in the floor plan, you'll see that the cursor not only snaps to those lines, but also adapts the thickness of the wall based on distances it detects between nearby parallel lines. So with this, Wouter can very easily trace the complete floor plan and quickly transform it into a 3D model. So after completing the first level, we can simply duplicate it a number of times, add a flat rooftop, and with this we quickly have the outline basic structure of a building. Now Wouter can of course use all kinds of direct modeling tools in BricsCAD BIM to further sculpt this building, if you will, and he will now remove some walls. Right now he's slicing a number of the topmost slabs in the roof, and he does this to pull down a portion of the roof and quickly create like a lower wing to this building. So, and then we still have to close these gaps in the building, but there's a handy tool for that, the L-Connect tool. So this building is taking shape. But of course, conceptual design involves more than just the form of the building. We also want to add glazing early on in the design. And Wouter will now introduce some windows using the Window Create tool in combination with the BIM Grid tool. So he's just drawing a grid on one of the walls, loosely positioning it. It's not very important where it is at this stage. We can then just select it and call Window Create from there. It will transform this grid into a frame for the window and the glazing included. And now we can actually, it's an intelligent window, we can reposition it using the window dimensions to fit exactly where we want it to. Now of course this is only one window, we want multiple windows, we want windows on other sides of the building as well. We could recreate this window, or we could try to copy and move it around and reinsert it. But if you need this kind of repetition, you should try to consider using Propagate for this, even in this conceptual design phase. So that's what Walter is doing now. So quickly he propagates the window as a detail attached to a wall, and then by selecting which suggestions he accepts, which not, and by choosing some other options offered by Propagate, he quickly makes an interesting window pattern for this building. So, just to finish it off, we will add some slope to the roof. This is done just by grabbing some faces and rotating them with the manipulator, as you can see here. And after that, we will stop modeling on the outside of the building for this demo. We just want to work a bit on the inside of the building. We will be adding stairs to this model after this. So let me introduce you, tell me something more about stairs in BricsCAD BIM. Of course, we have a free modeler. We can model anything and model a stair from scratch, call it a stair, classify it as a stair actually, and it will have the correct IFC properties of a stair. But we also created a new tool, which you already saw in action, the stair tool, to help you to help facilitate the layout of your stairs. You don't have to do the calculations about the number of steps and tread length and everything. The tool does this for you and satisfies all restrictions imposed on stairs. So what you see here is a stair cursor. It's actually representing the first tread of the stair you're going to create, and the arrow indicates the direction in which the stair will start. You have these shooting dimensions to nearby walls to position it exactly, but it also snaps to walls, and as you can see, when it snaps to a wall, it also aligns with it in a logical way. So you can also manually rotate the stair by quarter turns if you want. But if you're happy with the first position, you can click and you enter a second phase of the stair creation. In this stage, you can see a preview of the stair you're going to create. And you have a cursor moving around on a different level, on the lower level in this case. And depending on where this cursor is, you get different stair shapes, straight flights, L-shaped stairs, or U-shaped stairs. And in the case of U-shaped stair, you still have two options to have one landing, two landings. You also see that at certain positions, the stair will go from light blue to darker blue, and the cursor also snaps to these positions. What this means is that at these positions, the tread length is exactly the ideal tread length that you specified in the settings. So if you're happy with the stair shape, you click a second time and the stair is created. And not only a stair, there's also an opening in the slab above it. This is kind of a minimal opening you need for the headroom you need to walk on this stair, and you can just start modeling from this opening to modify it to the specific needs for your project, for your building, which will be different each time. Walter will also demonstrate the last snapping feature of this stair cursor, which is to the edges of existing openings. So you can also start your stair from an edge of a slab, an edge of an opening in a slab, to quickly create it. So the stair object that we create in this way is classified as a stair. It has IFC properties of stair. It's also fully parametric. We will demonstrate that in a minute in the other main building of our demo. And it's a very basic stair shape at this point, but in BricsCAD, of course, it can be a starting point to further direct model on this. And in the future, we'll offer also more options right off the shelf for stair shapes with this tool. So let's now go back to the main building and start adding some stairs there as well. So Walter opens a section to be able to work very clearly on 2 floors. What he's doing now is he's opening the stair settings. There you can specify a number of options for your stair creation. And he's checking the final tread option here, which will add a tread at the same level of the slab we're starting the stair on. So with some snapping to walls, but the use of the dimensions that the stair tool offers, he can position the stair exactly in this corner. And he's also choosing the correct U-shape, and then a single push-pull to finish this opening. So the stair is not completely finished yet. Its width, we didn't have any options to change the width yet, but that's all done with the stair parameters. If you go to the properties panel, you can see a number of parameters that Walter can now start to change to finish up the stair. So what you can change is the width of the stair, of course. He can change the distance between the flights. He can change the length of the flights. until he's completely happy with the result. So of course, again, as with the window, we have one window, one stair, excuse me. We need stairs to go all the way up to the top floor of the building, and again, we could recreate this stair, we could try to copy repeat it upwards, but again, we think repetition, then we suggest to use propagate, and that's what Wouter is also doing now. He's selecting the walls surrounding the stair and the slab to which the stair is attached as base solids, a reference for the stair, and the stair then the detail, and then propagate finds for him other locations where this exact stair configuration matches. And so, like this, it's very easy to have all the stairs in the building that we need right now. And also note, not only the stair is duplicated, but also the opening in the slab that is needed for the stair is replicated by propagate. So while Wouter is finishing up this model, he has to attach these inner walls to the sloped roof. Let me introduce you to the next phase. So suppose, this is of course only a short demo, but we're happy with the conceptual design here. We've been freely modeling in 3D, not worrying about BIM stuff at this point. Then we want to move this model into a BIM stage. And the first thing we have to do is make sure everything is classified. So we have walls should be walls, slabs should be slabs and everything. And we have introduced the BIMify tool for this, if you would start from raw geometry. But since we've been creating the main part of this building using QuickDraw, everything has already been classified for us and has also been assigned to the correct elevations. And also the windows and the stairs have been assigned to the correct floors because Propagate did that for us. So we'll still run BIMify on this model because it will add some extra information. It will automatically detect the rooms in the building. And as you will see, it also adds these elevation and section planes, which will be handy when we start creating our sheet sets for this project. So at this stage, everything is classified, but if you look at a section, you can see there's still BIM data to be added. The compositions still have to be in place. Also, window parameters are still at the defaults. There's some touching up to do. And until V19, this was still a manual process, not a difficult one. It's just going to the compositions panel, dragging and dropping some compositions on the correct entities. But there's still some manual work to make the correct selection sets and mainly to avoid forgetting something. So you have to make sure you cover everything. That is not what Wouter is doing here, if you've noticed. He's just assigning a floor composition to one slab. He's assigning an interior wall composition to only one interior wall. He's assigning a roof composition to only one roof. This will be enough for BricsCAD to know how to finish this model. For the outer walls, we'll do something more. What Wouter is doing here is adding one composition to one front wall and one side wall, and a different composition to one of the back walls. This will be a blind facade. It will have different finishing. And also, if you look closer, you see that the layer thicknesses are different, perhaps because this needs more insulation. It's the north face, for instance. So before we call AutoMatch, because obviously that's what we're going to do, we're still going to change the window parameters for one window. We can experiment with one window to see what works. Here we want a bigger frame depth to give the window a bit more character. And obviously Wouter also changed his mind about the stairs, so he'll add a bit more thickness to the steps for one stair again. And then it's time to launch AutoMatch. You saw it in action on the main BIM demo. I'll give it a bit more explanation here what's happening. So you have a number of options of which information you want to complete. Here we want to go for compositions, window parameters, and stair parameters. And when we choose the autocomplete option, what AutoMatch is doing is it's trying to find a pattern in what Wouter just did. And then it applies this pattern to the rest of the building. So that's what happened in this moment. If you go to a section, you can see that every slab has the correct composition. All inner walls have changed composition. Also, the roof has the correct composition. And if we go to an arbitrary horizontal section, you'll see that the outer walls also have the correct composition, including the difference between the back side and all the other sides. If we look at a window, we'll also see that all window frame depths have been adjusted. And then finally, when we look at a stair, we'll see that all steps have been made thicker. So I think this is really cool, and it's a big time saver to finish up this part of the model, which is actually a lot of repetitive work, if you will. But AutoMatch can do more, something that has not been demonstrated, I think, at this conference. Suppose we're designing a larger site with different buildings that have different shapes but kind of the same style. So for instance, we have a smaller site building here. The same window style should be applied here and the same compositions. So what we can do is launch AutoMatch again, but this time specify an external file as the source. So now AutoMatch is going to this other file. We have to specify the file, of course. We will choose the file we completed a minute ago. And then it's analyzing this file, trying to find patterns in there and apply them to this model here. And as you can see, that went very smoothly. We have all outer wall compositions present. If we look at the back side, the same north side of the building, we'll also see that different composition has been applied there. The window parameters have been changed. So if you have multiple buildings with the same style, you can even imagine building your library of style examples to use with AutoMatch. So now we will go to detailing, and for that I will switch positions with Wouter. So please welcome Wouter to the stage.
Hello everyone, and thank you Jürgen for this nice explanation. So as we can see, and as Jürgen has explained, we actually went to two very important phases in the BIM workflow. We started with some prototyping, so we used QuickDraw and BIM Stair to quickly have an initial idea of the building. Then we added BIM data using BIMify and AutoMatch. And now we come to the next phase in the design workflow, in the typical BIM workflow, and that is adding more detail to the model. So we will actually increase the level of detail even more. So as you know, last year we introduced the new propagate tool, making it possible to model a connection once and then propagate it throughout the model. So as we also have seen in other presentations, we actually now have something new, which is the detail library, making it possible to create a connection, a detail once, save it in the detail library, and reuse it in all files that you would like to use. So now Jürgen is actually showing the details panel, which makes it possible to access the detail library. So you can see we have a nice folder structure with different categories. We also have a search bar. And there Jürgen will have a look to find a nice detail for this connection. So we've seen that we actually have a connection between two walls with a miter, but here we need something else. So Jürgen searched for a connection between two walls. And what we see here, we see some keywords. We call these things tags. So these tags are actually attached to a detail. We have base solid tags that are attached to the base solids, and also general tags that apply on the detail as a whole. So okay, let's add 2 times the wall tag. And if you have a look at the bottom of this panel, we can see that we actually have a custom search filter now containing 2 base solids and specifying that these 2 base solids need to be walls. But we can see now in the panel we have still 6 possibilities to match the connection, which is still too much. So we actually look further. We specify more information there. So here we see that the connection is between 2 walls having 5 plies. So Jürgen now types in 5 plies and adds it for the 2 base solids. Okay, we see that we have one possibility here, so one possible detail. If we have a look in more detail here, we can indeed see that it's a connection where the plies meet nicely together, and it's a connection between 2 walls. However, the ply thicknesses can be changed and also should be changed because we see that here in our drawing, the back wall is thicker than the other wall. So we need to do something smart here to solve this connection. Okay, let's now launch Propagate and see what it does here. In no time, Propagate has found all possible suggestions, so all possible locations to apply this detail. Of course, we don't need all suggestions because at this side here, the miters are already nice, so we only need it at the back side of the building where we have this thicker back wall. And indeed, we see that Propagate nicely matched the plies together, which is not evident because this wall is thicker. So now, of course, you're wondering, how did Propagate do that? What's the magic behind this? Actually, when we go back to the detail, we see that the detail is parameterized. So what does it mean? Let's have a look in the detail file. Of course, it's very important to note that a detail file is just a simple DWG file. So there's no magic there, no templates, no libraries predefined. It is just a simple file containing two base solids, so the walls, a detail volume, and a section. And these entities are put on dedicated layers. But you can see it's really simple to create these files yourself. There's no magic in there. Okay, now we go to the mechanical browser. And there we can see that we have a bunch of parameters and constraints. I'll explain later how they got there, but for now it's important that these parameters are used for, with Propagate to actually adapt the ply thicknesses, in this case, to match the target location. So now Jürgen will demonstrate this by animating some of these parameters. And indeed, you can see that while doing that, the thickness of one ply is changed. And that is how Propagate actually managed to match the target location. Okay, I already mentioned that it's important we have a detail library. So that makes it possible to save a detail and actually use it over different files. So now we go back to our initial model, which was created earlier on, and we'll apply this detail here as well. That's actually very simple by just dragging and dropping the detail onto our model. And in no time, you can see that Propagate has found all possible locations. Again, we don't need all of them because miter connections were nice already. But at the backside of the wall, of the building, we need a more detailed connection. And we can see that Propagate again managed to match the parameters in order to have a nice connection there. Okay, so now Jürgen showed how to use a detail from the detail library and apply it on different models. But we can do more. It's also possible to create details yourself from scratch in a model. And that is what Jürgen will try to do now. So that can happen, of course. Not too much. It's a real demo indeed, yeah. No videos here. It has been working hard for 2 days. Okay, of course we have some backup files here. So what Jürgen now will do is actually create a detail from scratch, because we don't have only connections between different walls. We also have connections between, for example, roofs and walls. And for that, we actually would like to have a nice connection as well. So when we go to a different section, we indeed see here that we still have to do some work here to have a nice connection. So Jürgen will do this by just dragging some plies together and also adding some more detail. For example, he adds a wall cap on top of the outer wall for some protection reasons. He will also add some block of cellular concrete there for insulation or structural reasons. And you can see in no time, actually, we model a more detailed connection between the roof and the wall. So to make it more realistic, Jürgen will add some compositions to the solids. And then we are happy with this detail. So let's now create a real detail of this connection. So we go back to the Create Detail panel, and we click the Create Detail button. So in this dialog, we can actually specify what is needed for the connection. First of all, we need two base solids, or several base solids, which are here the wall and the roof. We also need some more entities, some more solids. Here we have the wall cap and the cellular concrete block. And we also need to add a section, because we have a 2D detail, and that needs to be specified in a section, otherwise it's not possible to have this detail. Okay, so now we have all information, and we have a preview, which looks quite good. Okay, so now we come to the Save Detail dialog, where Jürgen will specify the category of the detail, where we can add an appropriate name. Also, we can change the thumbnail of our detail by having a nice preview. This will be nice in our detail panel later on. And we can see as well, we have here the tags. So these tags made it possible earlier to search the details. But we can also add some more tags. For example, the name of the project, so the name of the conference here. We can also add the fact that we have a wall cap in this detail. You can see we have now two kinds of tags. The blue tags are automatically generated, like a 2D detail, two base solids. And the orange tags are just custom created tags which we can add to the detail. More is also important. Okay, now we are happy with the detail, so we save it. And as simple as that, it is saved to our detail library. So now we can use this keyword, the wall cap for example, to find the detail in our library. And indeed, there it is. There's one important thing to mention here. We see that the detail is not parameterized. This is not a problem because we can also create and use non-parameterized details. But of course, you see us coming here that we will want to use this detail in our first model where the roof is slightly sloped. So that's why we'll actually parameterize the detail by clicking this button. What happens then, the BIM parameterize detail command is launched and we open the detail file. So if we go back to the mechanical browser, we see that the command actually created all these parameters and constraints. And Jurgen is now having a look into this angle, which is very important. While animating it, we saw that this was not yet very perfect, so it's also possible to add some more constraints. For example, some coincidence constraints between the faces of the wall cap and the concrete block. But we saw it was not yet perfect because the thickness of this wall cap was not yet preserved. So we add some distance constraints to fully constrain this detail. And while finally having a look at this animation, we are very happy and see that the detail actually behaves as expected. So you can see the BIM parameterize detail command creates a framework of parameters and constraints, but it's still possible to add some more constraints, some custom constraints. Okay, let's now have a look and apply this detail in our first model. So Jurgen will again simply drag and drop it onto the model, and in no time actually Propagate found the right suggestions here. We applied all of them, and when now having a look here, we can see that Propagate actually changed the angle to match the target location. Not only at all sides of the building. This is very cool, right? And not only did it change the angle, it also changed the thicknesses of the plies at the backside, because there the detail is also nicely connected. So not only the angle, also the thicknesses. And here in this view, we can see that we actually had a 2D detail, but Propagate managed to nicely fix the corners between multiple details. So we see that we have a nice connection there, and you're also having a closer look. All plies are meeting nicely together. So Propagate is really a very, very smart tool, actually. And not only on this first roof, but also on the second roof, where we had no wall edge on top of the roof, Propagate just created one for us, and so we have it for free. So we can see in a few steps, and actually a few iterations of Propagate, we added lots of detail to our model. So this would be very time-consuming if you would have to model this each detail yourself, but we can see like in 5 or 10 minutes, we did it very quickly. And also important, it was all in 3D. So thank you for that, and I give the word now to Xian and Andrej from the Slovenian team, which will show us some of the civil features. Thank you.
Thank you. Hello, my name is Andrej and working on a civil project. So today we'll show you with Xian the new civil functionality for BricsCAD V20. So when we started the civil functionality for BricsCAD, we had quite a good idea how the design or modeling of civil objects or infrastructure objects. By that I mean long linear objects like roads or rails or even some earthworks should go. But there were some challenges. For example, it needs to be the modeling. It's the modeling basically. Then it has to be easy to use because we would like to approach this technology not just for civil professionals but also to architects, surveyors, such kind of profiles which are not all the time on the civil design. It has to be accurate and powerful, and it has to be the platform at the end because we are working on platform. So for this demo we will show you how you can use the civil features to design the conceptual design of the road accumulation. We'll do some building path. So first we started with the surface. Surface is kind of main or core entity which can be used to represent existing ground, as in this case, or it can be used to represent some surface layers or some sub-layers of the, let's say, of the design. And in this end of this valley, we will create accumulation dam. So to do that, we'll first create a simple line. And that simple line defines the crown of that accumulation dam. So from this element, we'll first use the grading entity and create offset and slope grading to the left and to the right side to design the top surface of that accumulation. Then we'll use the grading several times to create a side slopes for this accumulation dam. And all the gradings are so dynamically connected with the, let's say, reference elements, in this case, the line. So if you move the line, as you can see, the design updates automatically. It does not update in the real time with a full precision, of course, because we wanted to make it fast and help designer to see what will be the result of that move. So it's created with some, let's say, not full accuracy to be fast, but when you release the mouse, it's created with a full precision. Then, if you, for example, change the width of the first grading on the right side, also the second one updates because they are connected. So all the entities have the logic inside to be connected to enable this, let's say, functionality and expected behavior. So next, we would like to calculate the volume of this element. So how to do that? First, we need to merge or to join so different grading elements into a single surface. So now we have two surfaces in the drawing, so existing ground and that the second one which represents the accumulation dam, and we can calculate the volume just by selecting two surfaces. So the thin volume surface was created, and then that is, let's say, another entity, part of the civil, let's say, platform, and you can see some custom properties like cut volume and the fill volume. So you can immediately see what would be the volume of that element. So, and then you can, of course, you can play with it and see the results immediately. Not just the volumes, we can also create the solids. So if we have the surfaces which let's say closes the body, then you can create a solid or mesh in this case from such irregular geometry. Okay. So now we will use merge surface again to combine those existing ground and the accumulation surface into one surface, and we will use that, let's say, combined surface for the further design. So now we'll do, we would like to do some building path. So first, we would like to put the building path somewhere there, but as you can see, the surface, it's kind of bumpy. So we have this so-called smoothen command, with which you can let's say, go over the surface, specify the radius or any other closed polygon, and by, so let's say, selecting the area, this part of the surface is flattened or interpolated to get kind of smooth result. So it could be very useful for some, let's say, landscape architects if they get some surface from, let's say, not so nice data, to polish it a little bit and to have a nice, let's say, surroundings. For the building pad, we can create a building pad, let's say, in two ways. First, use deform surface command. So we select the polyline, define the inner boundary or offset, and with just this push-pull effect, we can elevate the bottom of the building pad to some defined elevation. So this is very handy if the outer and inner boundary of the building pad is defined and when it shouldn't change. But when we have the situation that we know the footprint, the one footprint, and we know the slope, then we can use the grading technology. So the grading technology helps you to create the side slopes with a certain angle to find the intersection to the existing ground, and such let's say irregular geometry is created. So again, the grading is a custom entity with some specific properties. Again, it is also, as you can see, it is related to the existing entity, and if you move around, it updates in the real time. So, but this functionality thank you. This functionality works also on large examples, not just on small ones. So then you really have a full freedom to find the right position, to set the right elevation. You can even select the side slopes and change the slope with the grips, or you can change the slopes in the properties, and you can immediately also see the fill and the cut volumes. So once this building pad is, let's say, set up, then you can use it to position, to place some buildings on top of it, and use it for some design. Okay. Now, what we would like to do, we would like to design the road. We'd like to create a conceptual design. So we are not doing the detailed design, but conceptual design. The road which goes from that one, the existing one on the right side, over the accumulation dam, over those hills, passing by the building pad. So to design the road, we need the alignments, because the road or other linear objects, they are twisted in space. They are twisted in horizontal and vertical direction. So you cannot just use simple polylines or any other known geometry in CAD. You have to use the proper geometry, and proper geometry means that you have straight segments, you have curves in horizontal, in vertical direction. You could also have spirals. We do not have spirals at the moment. We'll add them next year. And by those alignments, you can precisely define the center line or geometry of the road or other linear object. So designing the alignment, basically traditional way goes like this, that you design horizontal alignment in plan view and you design the vertical alignment in the profile view. We wanted to upgrade this to bring the new approach. We wanted to be able to design the alignments directly in the 3D space. So by doing that, we had to develop some, let's say, some technology which could help you to do that. So let's start with the alignment. You start the command, select the surface, and then you can, if you watch precisely, you will see near the cursor, here's one small circle, which helps you to precisely define the position on the surface. Otherwise, if we wouldn't do that, you get very quickly lost in the 3D space. So to offer the designer some, let's say, navigation or better orientation in space, we introduce that. And so she created the alignment. What she did, basically she created alignment in 2D. It's a horizontal alignment. Then the vertical alignment, so the surface alignment was automatically generated on the surface. That's the blue line. And also the design profile or the design vertical alignment was also created automatically. So to enable this initial proposal of the design. Of course, we enable also the traditional workflow where you can design the profile manually, but this, let's say, automatic approach gives you the first, let's say, approximation of the object very quickly, and it is also dynamically. So here in the profile view, you can see we have two lines, the blue one which represents the projection to the existing ground, which is bumpy, and the new one which is smooth, and that is the design, because the road at the end it needs to be smooth. And if you select this vertical, so the design profile or alignment, you can see we have some setting called accuracy factor, and with this parameter you can specify how this vertical profile is aligned with the existing surface. So this value goes from 1, which means we have a straight line in vertical direction from start to the end point, to 100 when it means that we consider all the points. All the values in between helps you to approximate this. So if we put now value, for example, 5, it's closer, it gets closer. If we put it 10, for example, it's get more close to the existing surface. And by that you can control very easily the first approximation, and automatically also those entities, so for alignments we have horizontal, vertical, and 3D, are connected, and they are updated automatically. So now we have the alignment. We have the 3D alignment, and we will again use the gradient technology to create a road surface aligned with that alignment. So if you so let's say this is our first, let's say, version. So if we select the 3D alignment, you can see we have some special grips. By moving the grips, you can directly edit the 3D alignment. So no need to go to the 2D view, to plan view or profile view. You can do the edits of the geometry directly in 3D space. This is something that you cannot find in other CAD platforms or products. If we now switch from automatic to manual update mode, you can see that we have some additional grips, more arrow looked like, and now with those you can edit the geometry in the vertical direction only. So, and you can see the grading follows. And what is the beauty of this, that you immediately see how this, let's say, object or let's say road in our case will be positioned in the on site. Okay, so once we are happy with the road surface, then we can create side slopes. For side slopes, we will use the grading again, select the existing one, select the surface and set the slope, and we get, yeah. So if the objects are along, it might take some time. So we put the notification so to change the tessellation value to have the solution faster. Okay. So once this road corridor, let's say, is created, then we can join them to make a single surface. And when we have two surfaces, again, we can calculate the volumes. We can calculate the volume between existing ground and the road surface, and you can see we get again the thin volume surface with the exact cut and fill volumes. Okay, and when this, let's say, now we can use this road corridor for a boundary, as a boundary for the existing ground. So we can cut off this part of the road corridor from the existing surface to get such nice, let's say, view of the road, and that would be quite good. I mean, or to use it for the visualization, because you can immediately see where the new let's say, object will be located. Okay. Next thing, what we would like to do, we would like to fill this accumulation with water. So again, we can simply use deform command, specify the surface, specify the location, and this flat surface is created in that area. In our case, it represents the water, and we can also calculate the volume. What is the volume of this accumulation? So again, thin volume, select one and the second surface, and we got this result, this let's say, entity again, and you can see what's the value, 48,000 cubic meters. Okay, so for the end, what I would like to say is that we are working on a platform, and for the platform, it's very important that it has the powerful API. We have developed, or it exists, the .NET and BRX APIs for the thin surface, thin volume surface, and the grading. So it will be available in V20, in the first release. All the civil functionality will be available in BricsCAD Platinum and BIM. Maybe for very end, I would like to show you how we can create very simple API demo. Just let me switch the computer. Okay, so the same example as we used before. So with the API, you can use the API to do some specific functionality related to local standards or even companies, or you can automate some tasks. So with this simple example, what will do, it will automate the tasks, so it will create an accumulation, it will join the surfaces, and it will create a water surface at the end. So civil, it's just a simple example. So first I will select this arc representing the crown. I will select the surface which represents existing ground, and you can see now we create a water levels for the different elevations. So first you can calculate the volume, you can do the analysis, you can do the simulation. So if we hide this, you can see we have several surfaces here for the different elevations, and we do have let's say cut, fill, just fill volumes in this case, and to the areas for different let's say levels of the water in this case. So thank you for now. I would like to introduce Flare and sorry.
Here I am already.
Yeah, please introduce you.
Thank you. Hello, everyone. I would like to thank the previous demos because they allow us to go further, because we are all here to really see a BIM workflow in action. We want to start off with Bricsys 24/7, where we will upload everything onto the cloud that we made previously, so that you could work together and allow a workflow. We will start with the web interface because this allows us to show the administration tools that are present in Bricsys 24/7, our online cloud sharing platform that you certainly heard about already. So this is the interface, the new interface that we will launch. It is you can see the overview of all your projects, and you can set up a new project if you would like to. So you can add some information. But if we go to the Bricsys conference 2019, we can see the dashboard with the little icons that show you the DWG files that are already uploaded to the cloud. But we will start off with the administration tools, like I said. Here you have a detailed overview of the project, and you can go to documents to add some statuses that can be uploaded when people upload their document onto 24/7, just like a draft or a final version. If you then go to roles, you can define a new role, such as contractor B, for example. This will allow you to specify some access rights to the files later on in the process. So you have different roles. You can add people to the role on creation, or you can edit the role afterwards. And then you can see the overview of who already has this role and who will still need to be added. So if we now go to the project setup, you can see our folder structure that is in our project. And you can see that there are folders and that you can set the permission per role for the users that are in your project. So that's pretty cool. If we go to administration, you can still see the administrators of the project, and you can individually give them more or less access rights as well, because not everyone might need to do the same thing. We will now go to the documents to show you the overview of what is for everyone visible. So you have the activity button where you can find all the activity that is done in the last couple of days, and some details of the project again. If we go to documents, we can go to Hillside Offices. That is the project that we are working on right now. We see that we have a bunch of files uploaded, also a subfolder with sheets. And if we go to a model, for example, main, we see a little bit of the information, general information. But we can also go to the revisions and see all of our revisions and revert back if necessary. And in communication, you can find the communication around the project. For example, I asked Xian to check some interferences, and she still hasn't replied yet, but whatever. And then we can also go to attachments, and there you can find an overview of the attachments that are in your project and that your project is part of. So that's quite useful for a quick overview of what your file contains. We then go to BricsCAD because in BricsCAD V20 we have the new Bricsys 24/7 panel, which is quite convenient because you don't have to change from your model space anymore to go find and download your files. If you select them all, you can download them with one click. And if we see the loading icon for the files that are being downloaded. We see updated when the files are updated, and if you double click on a file, it will open. We will now open the main model, and this is the main drawing in which we will bring all the files together. As you can see here, we have the main building already in place, just like the site that were created previously, but we don't have a second building yet. So we go to the attachment panel, and we attach an XREF, or external reference in long. An external reference is a reference to another DWG file in a DWG, so that you can bring back models together and you can view them together more easily, or you could work together on different parts of models and ease out your workflow. So we now uploaded the we now inserted the second building, and we want to upload it back onto 24/7 since we have made some adaptations. So you can upload it to 24/7 by right-clicking, and you see that now it's locally modified. We can also give a status like specified before, and a description like XREF attached. We then can lock some files if we would like to, because we are going to work further onto the second building. And if you lock a file, you make sure that no one else can upload the same file in the meanwhile. So there is no risk of getting overlap in the drawings. So we locked the second building, and now we are going to create a project, because we now have combined all the files together in one DWG, but we don't have a real project just yet, because we also had some sheets onto 24/7, and these are not, you cannot attach them as XREFs because they're not really models. So we create a project for that. Here you see the project setup, and this is the file path that we are in, and you see all the files that are in this file path. So first we have the sheets with the sheets in there, and then secondly we have a .basis lib file. You might not recognize this file format in the first instance, but this is actually a database that contains spatial locations, compositions, and so on, so that you can share this among your external references. You also see the little icon that shows you what is the master file, and that's the file that we're working in. You then can go to sheet set. If you give this a consistent naming, you can keep all your sheets together in this file. And that's how you give it a consistent naming. And if you go to models, you can include or exclude some models as you wish. We will not include sheets and site because sheets are not really models, like I already said, and the site because we just don't feel like it for now. Then in the project library, you can find all the libraries that are attached to the DWG files in our building, and you see that they are all the same, so that's good. So they will be all shared the same library. So if we then go to sheet set setup, this is where the sheet set shows you all the sections that are in your project, and you can click them on and off as you wish. But you also see something else, and that's the current destination. The current destination gives you the current sheet that the section is on. So if we now go to the second tab, the Sheets tab, we see that no sheets are actually generated because BricsCAD will not override already existing sheets. So that's very convenient, and we will make some new sheets later on in this demo. Here you have also some configuration options like margins and naming. Then we see that the project is created, and we have 4 tabs. The first tab is sections. There you can find again all the sections that are in your project and easily navigate to them. The second tab is schedules, and here you can add schedules. We will also do this later in the demo, but basically it is to make quantity takeoffs. Then the next tab is the Sheets tab, and as you can see, BricsCAD is downloading the files in the background. So we now have a very convenient and automatic background updating that will show you what is still being updated, so the little loading icon, and what still needs to be done, so the little cute red, orange dots. Lastly, we have the models. This is, you see that site is not there as expected, so we can change that to go to project setup and include site after all. And if we then return to the models, you can see that site is now added. We then you then might wonder, yeah, what if I now want to add sections or sheets to my project? Is it still possible? Because, yeah, it might seem fixed or something, but nevertheless, it's quite easy to make new sections and add them to your existing project. So we will now make the sections of the second building, because the second building has no sections just yet. So we will run Bimify, just like Jürgen and Wouter did, to make the sections very easily. If we then go to the properties, we can change the scale to 0.01. And this is because this is the standard that the sheet set setup will use as beginning point for your scaling. If we then go back to the main file, we see that if we reload the XREF, we will see the sections appear. And you won't only see them in the model space, you can also see them in the project browser, so they just appeared. And now we can go back to sheet set setup. And you now see that there are some files which don't have the current destination in place just yet. So if we now go to Sheets, you can find that there is 2 sheets being generated, and that it nicely fits onto those sheets. But if you would still like to change the scale, you can do still in this project, in the sheet set setup. So if we would change the scale, and would go back to the sheets, then we see the little rectangle turns red, because this is not a valid, well, it doesn't fit the sheet anymore. So you also see that BricsCAD created 3 sheets instead of 2. This is because the second floor didn't fit on the first sheet anymore. So it's very convenient that BricsCAD adapts itself to that. And if we change back the scale, you will see that there are again 2 sheets instead of 3. If you would like to put sections and plans on the same sheet, it's still possible in the configuration by changing the naming. So we now see that also these files are updating, and that they are queued. But you can also manually update them if you would like to, because the process might be not on the page that you would want to. So you can go and update them yourself. So if we now go to the floor plan, we see the section that's being generated. We see the wall cut through. We see some tags that are automatically placed. But what we don't see is the furniture. You might wonder, we had some furniture in there. Where did my furniture go? Well, it's not gone, luckily. It's on a dedicated layer called the BRX layer. This layer contains the symbols of the 3D geometry, and if you have a component, for example, and add a 2D drawing to that component and put it on the BRX 2D layer, then you will be able to see it when you turn on the BRX layers. If you would want to have the 2D section and a symbolic representation, you can always use the BRX 2D Plus layer, because then, just like in a door swing, you have the swing symbol and you have the cut-through door. So that's very convenient, but we see that BricsCAD made a bunch of other layers as well. These are conveniently named into 3 groups. The first is background. In background, you can find all the lines that are just in the background of your section plane. Then if we go to boundary, we can see the boundary, the boundary line of the cut-through object. And if you go to the fill, then you see the hatch patterns of the cut-through volumes. And if we would turn, you can individually turn on and off plies, because the second part of the naming is just as the ply material has been named. If no plies would be added, then the layer name will be the second part of the naming. And then we can also change the colors if you would like to, but this you might not want to do in every drawing separately, so therefore we have templates in BricsCAD. You can really store anything that you want to fully customize your drawings in the future. Then we can also change the hatch pattern if you would like to. This we will show on an elevation. If we go to an elevation, then you see that if we wait a bit and update it first, I guess, then we see that it is still empty now. But if we, in V20, we have a setting called Generate Elevation Fill. It's a property in the section plane, and if we turn that on, you will be able to see the elevation after all. This elevation is specified in the composition of a wall. So if we would change the composition, we will also see the hatch pattern appear. That's what we're going to do next. So here you see that the hatch pattern has been applied, and I needed to take a sip. So the hatch pattern is there, but we might wonder which composition do we need to change. Well, if we select a wall and go to the properties, you see that the composition is cavity wall front. And we also see that the wall type is wall type 1. This is what is being placed onto the tags at the moment, so that you can notice it in the future in this demo. So if you if we now go to the compositions and change the layer, change the plies. The first ply is the front bricks. It's this ply that you will see displayed in the outer elevations. So you can change the section hatch, and you can change the appearance of the hatch, the elevation hatch. So if we now regenerate the elevation, then we will see that in just a few seconds, it changes to this new hatch pattern, which is pretty cool that we can now do that. If we go to the floor plan, you can also see that the hatch pattern of the outermost ply face has changed. And you see, oh, well, now it's changed. And you can also see the wall tag that displays wall type 1. You can fully customize these tags, but you can also place the tags manually, just like the composition tag. If this will display the composition fairly easily, so that you don't have to manually insert it all again. If we go to the wall, if we added the block that makes up this tag, then we can fully customize it. It is possible to display any property that you want in the tag. So if we now would like to change it to composition and then underneath it display the thickness, it is very easily possible. You can also delete the rectangle to have this tag look better, or make another symbol or whatever you like. So if we update the section, you can see that all the tags change and that it is just as we expected, the cavity wall front. Then we will end the annotations with some dimensions. These dimensions will be placed on some interior walls. And you might wonder, yeah, but if I annotate, I can't change anything in my drawing, in my 3D drawing probably, because it won't update. Well, in BricsCAD, this is not true. It will automatically update itself, so that's what we are going to show you next. We will drag some interior wall, and then we will also delete the couch just to show you that the plans are really real-life or real-time rendered from your 3D model. So if we just update it, then you see the dimension changes. It changes value as well. So yeah, I really like this. I guess you can all agree with me that this is very useful. And to conclude, we will, I don't know what is happening now. Oh, yeah, we will show you first some some pre-made sheets to show you what is possible. So we placed some dimensions here. We're not full-blown architects, so it's probably not what you're used to, but at least it's a good start. And you can see that the profiles also have a tag. And this is in an XREF, so also data from XREFs is shown in your model. And if we go to the section, you can see that also the furniture is nicely displayed, that we have the connections that we want, and so on. We also see the background that has an elevation hatch. If we go to the details, that's something that we also can do in BricsCAD, that's making detail sections. You saw a wall and now a roof wall connection. And to conclude this sheet, we can show you a landscape render just made in not even a minute, and it immediately shows you a better visualization of the section. So if we then go to the last sheet that we have prepared, it's the elevations, and you can see the elevation lines as well on there. And the last thing that we want to show you are the title blocks. These are pre-made in a template, and you can just specify the template. You can add some attributes and name them, give them values, and if you give those values already in your template, then you won't have to do it again for every sheet, so that's pretty convenient. That concluded the sheets, and we can now go to the schedules. So we just are going to quickly show you to make a schedule from some windows. We have a pre-made template that stores the information that we would like to generate from this drawing, and we can give it a name and specify a sheet to place it on. This is all fairly easy, and if we go to the properties, you can still select or deselect some properties. And if we just wait a bit and open it, then we can see what we actually generated. It's the name of the window is obviously there with the quantity. So you see that there are two windows on the floor 0, and that they have the specific height and width and some extra parameters. And to conclude, we have a nice elevation that shows you a bit in context what we are talking about. So that were the sheets, the schedules, and we now have fully made our project. We could upload this back onto 24/7 to conclude our workflow, and then we are finished with this BIM workflow. We started off with some direct modeling. We added compositions, we added details, we used auto match, we created a site, and then we bundled it all together, uploaded to the cloud, and here we go. We have a full BIM workflow. So then there is nothing else for me to say than see you at the after party.